Okay, D03, one-dimensional friction, problem number 5. It says a man finds he must exert a horizontal force of 700 newtons to get a 200 kilogram couch to barely move. Once the couch starts moving, the man continues to push with 700 newtons and the couch accelerates at 1.10 meters per second squared. A, determine the coefficient of static friction between the couch and the carpet. B, determine the coefficient of kinetic friction between the couch and the carpet. Okay, so let's take a look at A first, obviously. Determine the coefficient of static friction. So it says that he must exert 700 newtons to get a 200 kilogram couch to barely move. So we're going to say that that's what it takes to start the motion. Okay, so we are looking for the coefficient of static friction is equal to what? All right, so let's draw our force diagram. Fortunately, our force diagram is going to be the same for both of these. So we're going to draw one diagram to satisfy both. It's a 200 kilogram couch. Okay, so that means we have the force of gravity, we have the normal force, we have the applied force, and of course we have the force of friction. Okay, so let's see what we know. We know that the applied force, so our applied force is equal to 700 newtons. Okay, we know that the mass is 200 kilograms. Okay, and that's it. That's all we know for part A, and that's all we care about for part A. What we need to figure out is what is the normal force, okay, and the force of friction, because our coefficient, remember the coefficient of friction, or the coefficient of friction, the coefficient of static friction is equal to, is equal to the force of friction divided by the normal force. So once we find those two things, we're good. Okay, so we need to realize that the normal force and the force of friction, when we're talking about one-dimensional motion, are equal to each other because we're not going up or down at all, we're only going left and right. So our normal force is equal to the negative mass, so negative 200 kilograms, times our acceleration due to gravity, so negative 9.8 meters per second squared. Okay, so our normal force is equal to, let's see, so negative 200 times negative 9.8 meters per second squared. So if I do that on the calculator, get approximately 1,960 newtons. Not approximately, get exactly 1,960 newtons. Okay, and so our force of friction, remember we're getting it to barely move, so it's not accelerating yet. We're getting it to barely move, so that means that our force of friction and our applied force are basically the same. Okay, so they're basically the same. So we're going to say that our force of friction is also 700 newtons. Okay, so our force of friction to get it started is 700 newtons. So therefore the coefficient of friction, coefficient of static friction that is equal to our force of friction, which is 700 newtons, divided by our normal force, which is 1,960 newtons. So we get a coefficient of static friction of 0.357, or based on our significant figures here, is 0.36. Okay, so that takes care of part A. Part B, it says determine the coefficient of kinetic friction. So now we need to find out the coefficient of kinetic friction. Okay, so the coefficient of kinetic friction, okay, we find the same way. This time, though, we have to take a look at the acceleration. Okay, so the couch is accelerating at 1.1 meters per second squared. So what we need to do is figure out what is the net force. So first figure out what is the net force acting. Okay, so the net force, of course, is equal to mass times acceleration. The mass is 200 kilograms times the acceleration, which is 1.10 meters per second squared. Okay, which gives us a net force of 220 newtons. Then we can figure out the force of friction. Okay, the force of friction is equal to the net force, which we just found, minus the applied force. Okay, so the force of friction is equal to 220 newtons minus the applied force, which is 700 newtons. That's what we've been using all along. The applied force is 700 newtons. So that means that my force of friction is 480 newtons. Technically it's negative 480 newtons, but it's 480 newtons to the left, so we are going to just look at it in terms of its magnitude. Okay, so the magnitude of the force of friction is 480 newtons. So to figure out the coefficient of kinetic friction, we take that magnitude of the force of friction, which is 480 newtons, okay, and then divide that by our normal force. Remember, our normal force hasn't changed. It's still the 1,960 newtons that we found in the first one. So 480 divided by 1,960 is 0.24. So our coefficient of kinetic friction is 0.24. All right, moving on to number 6. Okay. We now have a 135 kilogram golf cart that's traveling at 20 meters per second. Okay, so it's got a constant velocity, 20 meters per second, on a surface with a coefficient of kinetic friction equal to 0.510. It says, what is the kinetic friction force? All right, so let's go ahead and draw our force diagram. We're going to draw the force diagram down here. We're going to be using it for both of these, so we may as well draw them together. So we've got a 135 kilogram golf cart. Force of gravity, which is equal and opposite to the normal force. Okay. We have some sort of applied force. Okay. And then we have some sort of force of friction. In this first one, because we know that it's at a constant velocity, that means that the acceleration must be 0. Okay? So if it's traveling at a constant velocity, that means that the acceleration must be 0. So the only thing that we need to determine, okay, in this first one is the kinetic friction force. So the force of friction, okay, so the force of friction is equal to the coefficient of kinetic friction times the normal force. Okay, so we can figure out the normal force. Remember, the normal force and the force of gravity are equal in opposite directions of each other. Okay, so to figure out the normal force, we take the negative mass, negative 135 kilograms, times negative 9.8 meters per second squared to get a normal force of 1,323 newtons. Okay, so then if we just plug that in and multiply it by our force of, or excuse me, our coefficient of kinetic friction, so 0.510 times 1,323 newtons gives us a frictional force of 675 newtons. Okay. For B, it says, what distance will the cart travel if it's allowed to coast to a stop? Coasting means that the engine was turned off and that the applied force disappeared. So what that means is our applied force just went to 0. Okay, so we have no applied force. So what we need to do is figure out what is the net force acting on the system. So what is the net force? Well, the net force right now is just that force of friction that we determined in the first one. So the force of friction plus the applied force is going to give us our net force. Well, our applied force, we just said, is 0. Okay, so that means that the net force is the same as the force of friction, just acting in the opposite direction. So if our net force, then the magnitude of the net force is 675 newtons, of course acting to the left, okay, and that means that we can now determine our acceleration, because the net force is equal to mass times acceleration. Well, so determine our acceleration, we just divide both sides by mass. So therefore, if we plug in everything that we know, net force gets plugged in right there, 675 newtons for the net force, 135 kilograms for the mass. So 675 newtons divided by 135 kilograms gives us an acceleration, and that should be negative 675 kilograms, gives us an acceleration of negative 5 meters per second squared. Okay, so negative 5 meters per second squared. And then we want to find out what the distance is. So looking back at our equations for distance, we have a final velocity of 0. So we're going to use our equation final velocity squared equals initial velocity squared plus 2 times acceleration, which we just found, times the distance, which is what we're looking for. We know everything here. We know that the final velocity is going to be 0 because it's coasting to a stop. Okay, we know that the initial velocity is 20 meters per second because we were given that. So 20 meters per second, we're going to square that value, plus 2 times our acceleration of negative 5 meters per second squared, okay, times our distance. Okay, so that's 400 meters squared per second squared, plus 2 times negative 5 is negative 10 meters per second squared, times distance. So if we subtract the 400 from both sides, negative 400, equals negative 10d. I dropped the units just to save a little bit of time. Divide both sides by negative 10. So the distance is equal to